Hi, this is our group project by Daniela Fabula and Isaias Ledesma. So the problem we decided to do is number 27 of page 567. So right here we got 4 lines. When we plot all these lines, we're going to get, we can draw the shape that's inside of this. And in this shape, we think the center of mass in this shape is right here. Now, so the first thing we're going to do is we're going to find the moment of x. Now for the moment of x, we use this formula right here. M sub x equals rho times integral of f of x squared minus g of x squared all times 1/2 dx. Now for this, we got our f of x and our g of x from these lines right here. Now, plug it in. We're going to get, this is going to cancel out to 0. It's going to be e squared x, and we'd like to move that 1/2 outside right here. So now this looks like a u substitution problem. So we're going to let u equal 2x. So du is going to equal 2 dx. And dx du over 2. And this is another 1/2 right here. So we like to move that outside as well, like you saw right here. So now we also plug in our limits of integration onto the u's. So now we get new values right here, 0 and 2. So now it's going to be integral of e to the u du, which is simple integral to solve now. So what we do is plug it in, and now we're going to get rho e squared over 4 minus 1/4. So we're going to get the moment of the x-axis, which is approximately rho 7.13, or you can keep it in this form. Now for the moment of y, it's a very similar formula, only that instead of 1/2, we're going to use x right here. And these two terms right here, these functions don't get squared. So now it's going to be m sub y equals rho limits of integration 0 and 1, and x ex minus 0 dx. So this goes away. So now we're going to get x times e to the x dx. Now this right here, we can actually do integration by parts. So we decided to do the tablature method. So diagonal x times e to the x minus 1 times e to the x right here. So it's going to be this, and then we plug it in, our values, and we're going to get rho e minus 1. Now for the next thing that we're going to do is we're going to figure out the centroid. So it is actually coordinate, so we have to find x bar and y bar. So for the x bar, we have a very similar one to the moment of y, only now we have to multiply it by 1 over area. And to find area, we have this other formula right here. So it's a 2-step process now. For area, we plug it into our integral. It's a very simple integral. And we get e to the x integrated. And then this is equal to e minus 1 right here. So area is equal to e minus 1 or 1.71, however you like it. So for right here, we plug it in, and now we're going to get integral limits of integration is 0 to 1, x e to the x 0 dx. And now this all solves to 1 over e minus 1 right here. So 0.58197, and this is the x coordinate that we're going to need to find the centroid. Now for the y coordinate, it's actually another formula that's very similar to the one in the beginning for the moment of x. Only now we also have the 1 over a. And because we found a, it's much faster now. So we just plug in a and just set up the integral. And now we're going to get 1 over e to the 1 and then times 1/2. And then this is going to get integrated. What we learned from the last one, the u substitution, we move 1/2 right here. So it's going to be 1/2 times 1/2 times 1 over e to the 1. Now, so that's going to be 1 to the 4, e minus 4, e to the 2x. And so right here, we notice that this will actually equal e squared minus 1 right here. So what we're going to do is we're going to actually factor this out. So we can get an e minus 1 and an e plus 1 out of this. And right here, we factored out the 4, so we have an e minus 1 right here. So as you see in this next slide, these cancel out. So we're going to get an e plus 1 over 4. So y bar equals e plus 1 over 4. So this is going to approximately equal 0.92957. and this is a y coordinate. And now for the mass, it's a very, very simple integral, actually. One of the easiest right here. And we do this, and then it's going to equal rho e minus 1. Now, in conclusion, we've got the moment of the x-axis, which is rho 7.13, moment of the y-axis, which is rho 1.71, the mass, which is rho e minus 1, and the center of mass, which is in these coordinates right here. Or if you plug it into a calculator, you're going to get 0.58197 or 0.92957. And this is coordinates for that, for the center of mass. And that is it. Thank you for watching.